So let's talk about valid and invalid arguments. So we're going to look at an example. Let's determine whether the argument form is valid. And the argument form will be if P then Q, if Q then P, therefore P or Q. So remember that all of the lines except for the last one, these are all called premises. So we're going to determine this using a truth table. I have two variables, P and Q, so I'm going to have 4 rows in my truth table. Okay. And then you're going to put the premises in your truth table. So if P then Q, this would be true and false, and then here P is false, so these are automatically true. And then we have if Q then P, those are our two premises. So now you're going to look at the column Q first and then look at P. So true, true would be true. Q is false, so that's automatically true. That's a false. Q is false, so it's automatically true. And then we're going to have our final column from here, P or Q. True, 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 false. And then we look for critical rows, rows where both of our premises are true. So let's go ahead and circle our critical rows. So here, both my premises are true. So I only have a critical row in the first and fourth rows. And then you look at your final column here. And if you notice, in one of our critical rows, right here, we have a false. And so this means that this argument form, this is invalid, because I got a false here. Invalid. And remember, we had some argument forms that had names. So we had modus tollens, and it went if P then Q, not Q, therefore not P. This one was valid. We had modus ponens, which was also valid. It was if P then Q, P, therefore Q. And then we had the converse. We had the converse error, which is invalid. It was P, if P then Q, Q, therefore P. And then we had the inverse error, which was also invalid, in the form of that is if P then Q, not P, therefore not Q. Okay, so now we're going to shift. Let's talk about predicates. So remember that predicate is a sentence that contains a finite number of variables and becomes a statement when specific values are substituted for the variables. So an example of a predicate would be something like x squared is greater than x. Once I plug in a number for x, this becomes either true or false. So it would become a statement. So once we have predicates, we can talk about the truth set of a predicate. So let's look at an example here. Let's say Qn is the predicate. N is a factor of 15. And let's talk about the truth set, and it really depends on our domain. So if I say if the domain is the set of all positive integers, and the way we denote positive integers is with a z plus the truth set. So which positive integers are factors of 15? 1, 3, 5, and 15. But what happens when I change my domain of my predicate if the domain is the set of all integers, i.e. the z, the truth set, so 1, 3, 5, and 15, I still have those, but now if I'm looking at all integers, that includes negative numbers, so I have -1, -3, -5, and -15 as well. So really your truth set depends on your domain for your predicate.